All right, let's talk about the 5.2 mastery check over right triangle trig. So, number one, Nathan's watching bird watching from his boat, and he sees a turkey vulture flying above a beach 3 miles to the east. So we'll say Nathan's here, sees some turkey vulture up in the air, and it's 3 miles away, east. If he tilts his binoculars up 30 degrees to see the vulture, question wants to know how high is this turkey vulture flying above the beach in miles? It wants to know the distance of this, or the length, excuse me, of this side of our triangle. If we have an angle and we're trying to solve for the side opposite, it's given us the side adjacent, we are going to use tangent of 30 degrees is equal to x over 3 in order to solve this triangle. Now, one thing we could do is potentially plug this into our calculator, solve for x, we'd get the answer. Another thing we could do is recognize the fact that, hey, tangent of 30 degrees is the same thing as sine of 30 degrees over cosine of 30 degrees. And based on what we know about the unit circle, we could plug in 1/2 for sine of 30, root 3 over 2 for cosine of 30, do some math, and come up with our answer. But I want us to recognize the fact that this is a 30, 60, 90 triangle. And what do we know about 30, 60, 90 degree triangles? The proportions of their sides always stay the same. If the side that is opposite my 30-degree angle is x, the side opposite my 60-degree angle is going to be root 3 times that side length times x. So this side of 3 opposite my 60-degree angle is equal to root 3 times x times this side opposite my 30-degree angle. And so that means that x is equal to 3 over root 3. And when we rationalize, we get x is equal to 3 times root 3 over 3. Those 3's cancel out, and there you have it. X is equal to root 3. That's option B. We are ready to move on. Remember, there are lots of ways to solve these sometimes, but there's always most definitely a most efficient way. Second question. Triangle PQR has a right angle Q. All right. Sounds like a visual is going to be helpful, so I'm going to draw one. With right angle Q, say P is up here, R is down here. If sine of R, so angle R, if sine is 4/5 opposite over hypotenuse, what is the value of the tangent of P? Well, one thing already that I notice is that my hypotenuse length is 5, one of my legs is 4. I know that a Pythagorean triple is 3, 4, 5. So I don't have to use the Pythagorean theorem to actually solve for this side because I already know if I were to use it, I would get this side length of 3. And so if we're looking at P now, trying to find the tangent, it's going to be the opposite side, which is 3, over the adjacent side, which is 4. And there you go. Tangent of P is 3/4. Now we'll head down here. We only have these questions on our mastery check. So I'm just going to focus on those. Find sine of theta if cosecant of theta is 13/12. One thing I know is that sine and cosecant are reciprocal functions. And so if cosecant of theta is 13/12, sine of theta is going to be the reciprocal of that, 12 over 13. I'm ready to move on. Find secant of theta if sine of theta is root 5 over 5. This one is going to take a little bit more work because secant and sine don't have any special relationship. And so what I'm going to have to do is draw a triangle, kind of visualize what I have. Say theta's here, sine's opposite over hypotenuse. I'm trying to solve for secant of theta, which I know is 1 over cosine of theta. It's a reciprocal function. And so if cosine of theta is x, my adjacent side, over 5, my hypotenuse, secant of theta is going to be 5 over that adjacent side, over x. And of course, in order to find that, I have to solve for that third side. I have to solve for x. And I'm going to do that using the Pythagorean theorem. So x squared plus root 5 squared is equal to 5 squared. Gives me x squared plus 5 is equal to 25. X squared is equal to 20. Take square root of both sides. We get x is equal to the square root of 20. Okay, secant of theta is equal to 5 over the square root of 20. Now, of course, we know we cannot have a radical in our denominator. That's craziness. So we need to rationalize this function, or this fraction as well here. One thing I know is that the square root of 20 is the same thing as the square root of 4 times the square root of 5. Square root of 4 is 2 times square root of 5. Rationalize by multiplying both of these by square root of 5. Square root of 5. Bring it down here. We get 5 root 5 over 2 times root 5 is 5. 2 times 5 is 10. Excuse me. 5/10 reduces to 1/2. And there you have it. Secant of theta is equal to root 5 over 2. Okay, last question. So, we are walking to work by walking 1.3 miles north and then turning right 90 degrees and walking east for 3.3 miles. Our friend tells us that we could take Washington Street instead, which goes directly from our apartment to our workplace in a straight line. Question here is approximately how much shorter in miles is this new route compared to our original walking route? So, of course, in order to do that and answer that question, we have to solve for our hypotenuse. And we will do that by using the Pythagorean theorem. So 1.3 squared plus 3.3 squared is equal to x squared. When we plug all that into our calculator, we get 12.58 is equal to x squared. That gives us x of about 3.547. Okay, we want to know how much shorter this distance of x is than these two distances added together. So 1.3 plus 3.3 is 4.6 minus this distance here, 3.547. That gives us about 1 point, wants us to round our answer to the nearest tenth of a mile. So 1.05, that'll be 1.1 miles shorter. And that's our answer. And that is your 5.2 mastery check.